We are now done with level 1 using LED lights control system. In that project, I was able to work with LEDs and tact switches using the Arduino. This time, we will be working on an actual LCD screen. My name is Rainika Ala JPAD of Section B, and this is Level 2 Microprocessors. For this activity, the materials used are the following: my good old Arduino microcontroller, a 16x2 liquid crystal display, 2 tact switches, 2 10 kΩ resistors as biasing pull-down resistors, a 330 ohm resistor for the cathode, 3 1 kΩ resistors for the contrast VE, a bunch of connecting wires, and breadboard. I started working on this project by first understanding the pins of the LCD and how I will carefully connect them to the Arduino pins. The examples that can be found in the actual software also come in handy. I was able to fully grasp how to use the functions that will be essential in programming the codes. In finding the intensity of the backlight that is suitable for me, I experimented upon trying to see what it looks like with no resistor connected to the VO, and it was too dark. When I added 1 kΩ resistor, it is readable, but the backlight is still dark. I went on adding resistors until I achieved the right backlight, which led me to have 3000 kΩ in total. This is what my schematic diagram looks like, which are then reflected directly on the hardware. Let us discuss the connections thoroughly. I first connect the soldered LCD to the breadboard and start building connections. The VSS is the ground pin of the LCD, while the VDD is the power supply. Thus, they are connected with respect to their purposes. As for the VO, which determines the contrast of the backlight, has a series of 3 1 kΩ resistors connected to it towards the ground. The RS pin, which differentiates the command from the data, is connected to pin 12, while the enable pin is connected to pin 11. The anode of the backlight is directly connected to the 5 volts, while its cathode has a 330 ohm resistor in series to the ground. For the data buses, pins D4 to D7, they are connected to pins 5, 4, 3, and 2 respectively. As for the control circuit, there are 2 tact switches that are connected to the 5 volts power used as scroll up and scroll down mechanisms. The other side of the tact switches have 10 kΩ resistors connected in series to it towards the ground. In this task, we are assigned to display a math or physics problem which involves calculations with at least 3 variables that are represented by Greek letters. This is the problem that I created. It says, a plane has a takeoff speed of 80 meters per second and requires 890 meters to reach that speed. Determine the acceleration of the plane and the time required to reach this speed. Having 5 variables in this problem, I have used the Greek symbols nu, omega, delta, alpha, and tau. With that being said, let us now go over the code. Let's start with the pins. 12, 11, 5, 4, 3, and 2 pins are used to connect to the LCD. Pin 8 is for the scroll up, while pin 9 is for the scroll down. The variable page_counter has an assigned value of 1, and the Boolean function allows 4 possible situations set to low. For my custom characters, I initially created 10 characters to add this sign on the display. Yet I have recently learned that a maximum of 8 characters is allowed. So I have a character for my up and down navigation, also one for each variables, the final velocity, the initial velocity, acceleration, distance, time, and one for a squared symbol in the equation to be used later. Under the void setup, first in line is the function lcd.begin 16x2. This informs the microcontroller that the LCD that will be utilized is a 16x2 liquid crystal display. The syntax for lcd.createCharacter is that inside the parenthesis, the first thing is the variable and next to it is the value or character it represented. I make use of the numbers that are representing the unique characters. To display the up symbol, I use 0. For down, we have 1. The variable's initial is set as 2, 3 as final, 4 as acceleration, 5 as distance, 6 as time, and 7 as squared. In this part, the debounce is very important because it ensures that only a single signal will be performed by the microcontroller, so it will only accept one input at a time. Take note that the underscore up is for the scroll down button, while the underscore down is for the scroll up. This is the loop for scroll down. It simply means that when I press the scroll down button, it allows me to navigate until case 55. And every time I click it, the LCD prints the screen next to it. And when I reach the last case, it will automatically go back to the top when I click the button. The page counter +1 means scroll down. When the down button is pressed, it will also print the next page. But notice the page counter greater than 1. This condition means that I can only scroll up after the first page. Page counter -1 means scroll up. A switch case statement was used in the main program loop. The case number determines the page number, and enclosed with it are the functions and commands to be performed after clicking either the scroll up or the scroll down button. The break function is also necessary to provide limit and pause to the program. The function lcd.setCursor can be visualized as coordinates on the LCD screen. The syntax for this function is that the first value before the comma represents the number of column as to where you will assign your cursor. The value next to it represents the row. Since we are using a 16 by 2 LCD, we have a maximum of 16 columns and 2 rows. The LCD write byte is used to display the custom characters. The LCD print function directly prints what's inside its parenthesis, and it must be visualized as to where the text will be placed to avoid jumbling of words and overlapping of statements. Therefore, these three functions come hand in hand. This is the final demonstration of my project. Thank you for watching!